Chapter 4, Fluid Kinematics. All right, class, let's imagine we are looking at a big river. We are not worried yet about why the water moves or what is pushing it. We are only curious about how the water moves and how we can describe that motion. This is called fluid kinematics. Kinematics means studying how things move without worrying about what is making them move. Like when you watch people walking in a park and you just see where they go without asking why they're walking. In fluids, we have two fun ways to watch them. One way is like watching a duck floating down a river. You follow the duck wherever it goes. This is called the Lagrangian way. Another way is like standing still at a bridge and checking how fast water passes under you. This is called the Eulerian way. Both are useful for different reasons, but usually we stand at one place, just like the Eulerian way. Next, imagine you are standing on a bridge and you want to measure how fast the water moves at different spots. We can use little imaginary arrows that tell us the speed and direction of the water at each point. These arrows are called the velocity field. And just like you have speed, you also have acceleration. If the water suddenly gets faster, like when it goes downhill, we can also draw arrows for how much it speeds up. That's the acceleration field. Now comes something cool called the material derivative. Imagine you are sitting on a little boat floating down the river. You would feel changes in the water temperature or speed as you move. This total change felt by you on the boat is the material derivative, and it helps us connect both the duck-following view and the standing-on-the-bridge view. Then we have ways to see flows even better. One way is drawing streamlines. These are like imaginary strings in water that show us the direction water flows at every point. If you tied lots of little leaves on these strings, they would follow the water smoothly. Then there are pathlines, which show the actual journey of one little leaf floating in the water. Next are streak lines, like pouring dye into the water at one spot and seeing how it flows downstream. And there are timelines too, where you draw a line of dye in water and see how it stretches and twists as water moves. We also have some clever tricks using light. When hot air rises from a candle, it bends light and we can see wavy patterns. Scientists use things called shadowgraph and Eulerian methods to see these invisible flows. They don't need smoke or dye. They just use how light bends when it goes through different densities of air. Lastly, when we collect information, we love making pictures. There are profile plots, like drawing how fast water moves from the river bottom to the top. Vector plots use arrows to show how fast and where water is going. Contour plots are like colorful maps, showing where water is faster or slower, or hotter or colder, just like weather maps on TV. So you see, fluids are like little stories of movement, and with these simple tricks, streamlines, pathlines, streak lines, timelines, light tricks, and pretty plots, we can read their story even when we can't see them with our eyes. That's why engineers love fluid kinematics. It lets us understand the hidden dance of air and water all around us.